All right, I think we can go ahead and kick it off. Thank you so much for joining us today for the H2O Phase 3 participant webinar. Today, we're going to be just going over a few things. Clayton, if you could just go to the next slide for the agenda. Thank you. So we'll be covering just some background on the prize, going over the prize phases and awards, and then just covering that submission package and scoring criteria. And then just some housekeeping reminders. This webinar will be recorded, so it'll be made available afterwards if you need to access it. And then if you could just please stay on mute throughout the presentation, and we'll open it up for questions at the end. All right, and with that, I will hand it over to you, Katie.
Great, thanks, Brittany. So thank you all for joining today. Just a quick background. My name is Katie Jackson. I'm a technology manager at the U.S. Department of Energy's Water Power Technologies Office. This prize is being funded by the U.S. Department of Energy's Water Power Technologies Office, also known as WPTO. We look to enable research, development, and testing of emerging technologies for advancing marine energy and next generation hydropower and pump storage hydropower systems for a flexible, reliable grid. One of our WPTO research initiatives is the Hydrowires initiative. It stands for Hydropower and Water Innovation for a Resilient Electricity System. And the goal of Hydrowires is to understand, enable, and improve hydropower's contributions to reliability, resilience, and integration in a rapidly evolving electricity system. And this project this prize is being funded as part of the Hydrowires initiative. So the H2Os prize, the Hydropower Operations Optimization prize, is working to support the renewable energy transition in the US. We're wanting to apply expertise in hydropower, artificial intelligence, machine learning, data science, all these other fancy coding things. Advance the representation of hydropower in power system scheduling. With the grid evolving, we think hydropower could play a very key role, and we want to make sure that we understand all the capabilities and constraints related to hydropower's participation. And obviously, y'all are here because you want to compete for up to $75K in cash prize pool over 3 phases. So why this is important. Hydropower is one of the most flexible, firm, and clean power generation resources. However, the capabilities of the hydropower fleet remain largely inaccessible to power system operators due to a number of reasons that can include complex operational conditions when it comes to balancing water and a lot of those environmental needs, lack of incentives, asking why hydropower needs to participate the way it might be needed in a future grid, and a general incompatibility with power scheduling procedures. So we're looking to the competitors to help develop hydropower scheduling approaches to maximize the electricity production capabilities without violating water management requirements. So the competition objectives, we're looking for hydropower management performance, making sure hydropower scheduling solutions that respect the water system's physical and operational constraints, while also maximizing hydropower generation benefits, making sure the economic and environmental benefits resulting from the hydropower generation is actually feasible hydropower output, and that we're getting electricity market energy prices, and the solutions need to be novel, scalable, and broadly applicable to hydropower. So we want unique, innovative, and flexible solutions that can apply to a lot of different facilities with a range of modeling institutional frameworks. The prize is really trying to incentivize innovative modeling approaches to let hydropower realize the optimal energy and electricity system engagement while respecting realistic stream flow constraints. And so now I'm going to pass it off to Abby. Thanks,
Katie. Hi, I'm Abby. I'll be talking with Clayton for the remainder of the presentation, walking through phase 3 specifically and just general H2O prize background. So this slide probably looks familiar if you've joined one of the previous webinars, but just to sort of brief anyone who's new to the competition, part of the challenge is we've described a water system and the operations involved in that system, which includes two types of water system constraints. One, we've provided all the information to define the physical parameters of the system. So how big reservoirs are, how big their outlet capacities are, how their spill works. And then in addition, we've provided a set of operational water system constraints, which are considered soft constraints. So this is, ideally water management goals that your operation should try to meet. So that is meeting water supply demands or not exceeding a flooding threshold, or meeting a minimum flow requirement. And so the whole idea is, we want to seek a scheduling solution that respects these constraints whenever possible. And I'll pass it off to Clayton.
Yeah, thanks, Abby. So, of course, this problem is trying to incentivize the operation of a water system in coordination with a power system. So the power system representation is a scheduling problem, much like most regional operators solve to determine the next day's operation of the power system. So the goal here is to minimize the total operational costs or variable costs of operating generators to meet a specified demand at each time period. Constraints that there are constraints that govern each generator in the system. Those generators are the reservoirs that are reflected in the water system, as well as the thermal generators that are also in existence on the power system. And in addition to that, there are system level constraints to meet the supply and demand, or the load and generation balance in the system at each node in the transmission network. And then the problem also represents transmission network capabilities with a linearized power flow model, which is all laid out in detail in the rules document. And so the goal here is to produce a deterministic optimal power system dispatch subject to the submitted power production capabilities from the hydropower fleet. And then from all of this, we will calculate economic and environmental benefits based on the generation that is cleared from this dispatch problem. And so essentially, with these two sides of the problem, the water and the power side, we're asking competitors to act as hydropower fleet schedulers and try to maximize these hydropower capabilities without violating, or while trying to minimize the violations of water management rules. And so all of these schedules are subject to penalties for violating water system physical and operational constraints. And then the power system can create economic and environmental benefits from the generation that results. Note that in this phase 3, we are changing the relative value of economic and environmental benefits in the scoring platform relative to the other phases that we've created. So speaking of the phases, this problem structure remains the same as the previous two, except that the data itself has changed a little bit, just like the last transition that we went through. So again, we have provided a set of input data, power system data, water system data in the exact same format as the previous two phases. And then this problem being the grand prize of this phase, being the grand prize of this series, has a significantly larger and longer problem. So then with that input data, we expect candidates to prepare a submission, a water release in the form of a water release schedule for each reservoir in the system, and submit that to the top coder platform, which we'll talk about in a minute, which will provide a provisional score shortly after submission. then and then at the close of the competition phase, we will ask that competitors submit technical narratives, this available software, and a summary side that we will use to compile the final scores for each competitor, and then and ranked finally. Note again that the only score that counts towards your final score is the last score you submit. So even if you have a higher score earlier in the phase, that gets overridden by any subsequent submissions. Again, this third phase, $50K total prize purse, and we will announce the phase closes in November, and we will announce the winners. It's been taking us about a month to review with our technical team, and then with the DOE clients, and announce the winners afterwards. So the total purse is $30K for first, $10K for second and third, and we will close the competition on November 11th. One more time on the submission requirements. We are request at the close of the submission, only complete submissions will be scored, where the reservoir release schedule, which is of course required, the technical narrative is very important and helps us determine the feasibility of the approach. It's essentially a technical write-up of how you came to the solution that you submitted in the reservoir release schedule. And then the other required element is the summary slide describing your solution approach and any anticipated impact of the submission. The scoring breakdown. So we've divided the total score into kind of three categories. The technical narrative is the qualitative review that we do on the technical write-up. The hydropower management performance score is the technical score that comes from evaluation, the automatic quantitative evaluation of the hydropower operation performance, and then the water system operation performance. And then the hydropower generation benefits are the benefits produced from hydropower generation in the power system. So that's the power system evaluation. And those two are divided equally for a total maximum of 60 in each category. And then when you sum it all up, you get total maximum score of 150. The scores that are automatically calculated are out of 120 on the Top Coder platform, and because they don't include the technical narrative, which we review afterwards. So the way this all works is that we take in the submission from the competitors. We evaluate we run a water system simulation to evaluate the feasibility of the schedule and see if the schedule will violate any of the soft constraints that Abby mentioned, and then from that simulation produce a power production capability that is passed as an offer to the power system simulation, which acts much like a market clearing mechanism would, and will clear those offers up to the point that so it will dispatch the hydropower generators up to as much as the offer allows. And then in trying to minimize the power system operations, both of the water and the power system simulation results are processed to calculate the scores and then combined to create a normalized score. On the power system side, we are calculating both an economic benefit, which is the prices at the locational marginal prices at each node, times the total hydropower generation at each node. So we sum those up, and that's the total economic benefit. The total environmental benefit is the sum of the feasible hydropower time series times the benefit factor, which is effectively the offset amount of carbon emissions if the alternative were to generate electricity from a natural gas turbine. And then in this competition, we wanted to further incentivize people to maximize hydropower generation and not just chase profits from hydropower. And so we changed the relative scoring value by multiplying this environmental benefit factor by 10 from the previous calculation. So it's significantly more valuable to create hydropower environmental benefits in this phase than it has been in the previous two phases. On the waters, do you want to jump in, Abby? Go ahead.
Oh, I can. Sorry about that. I'll go ahead and talk through this. So yeah, on the water operations side, there have been no changes in the scoring mechanism for any of the water components. For each reservoir, there's a physical constraint violation, which is composed of two individual components, an inadequate release and an excess release. So if you released, less than what is feasible or more than what is feasible on any given time step, that's going to result in a very severe violation on your score. And then in addition, we have water management violations, which represent undesirable operations. And it may be that you cannot violate or you cannot satisfy the water management components on every single time step. So those violations are computed by looking at, on average, for the time that you do not satisfy that constraint, what is the average violation? And all of these individual components are summed and scaled to be that 0 to 60.
Thanks, Abby. And then again, on the technical narrative side, we have 5 criteria that we are evaluating the technical narrative on. We want people to demonstrate a clear understanding of the approach, describe and understand the limitations and how the approach could be generalized to different topics within the industry. And it should be scalable such that it can address problems in the industry. This phase is seeking to help demonstrate that as well. And then demonstrate uniqueness and novelty compared to current state of the art. And then finally, we want to understand how approaches demonstrate diversity, equity, and inclusion in their solution, and how they might impact diversity, equity, and inclusion in the industry and the population that this industry serves. We'll evaluate each of those on a 1 to 6 scale based on an expert review panel that we have solicited volunteers to help us review each submission. Just reviewing the format, one sticky point over the last few phases has been the formatting of the CSV file, that is the reservoir release schedule. It needs to be formatted exactly like this. It needs to take a range column with a date time formatted strings, and then it needs to have each reservoir name followed by underscore input release in each column, and it needs to take floating point numbers without quotations, without nans, without nas, without nulls. So avoid the Excel formatting if you can. If there's any questions with that, we can please post on the Top Coder forum, and we can try and address as quickly as possible. Finally, we'll go through a quick review of the data set that we've made available for phase 3. Go ahead, Abby.
Sure. Okay, so like Clayton mentioned, one aspect of the change, part of phase 3 is that we did elongate the problem to be a solving 3 months. So there is a longer time horizon. The general setup of the reservoirs and how they're connected is pretty much the same as phase 2, but we included several additional operational constraints. So you can see below reservoir 4, there are 3, I'll call them diversions, but those are water supply demand points. So any water that's flowing, below reservoir 4 is going to be subject to those demands, and they will be satisfied in the order from upstream to downstream. Below reservoir 1 and reservoir 4, there's a flooding threshold that flows into reservoir 2, which is essentially a run-of-river reservoir, but there is a small amount of storage that can be managed if desired. Below reservoir 2, there's a local inflow, and below that confluence of reservoir 2's outflows and the local inflows, there's an additional flooding threshold followed by 3 water supply demands, and then reservoir 3, and for the first time we have an operational constraint below reservoir 3, which is another demand to satisfy. And the other kind of major difference on the water system side is the hydrology is designed such that we're asking, schedulers to be able to manage a large event followed by kind of a dry spell. So that's kind of an additional part of the challenge. I think we should just skip over this table because we only have 5 minutes left. So this is just sort of the numbers, but please feel free to post on the forum if any of this is unclear in the dataset document. Just keep going. We have it in the dataset document. Yep.
Exact same format as last time. And on the power systems side, there are really no changes. The only change is the duration of the load time series that comes with the problem. So same power system network, same set of capabilities for thermal generators and line limits and things like that. Like I said, the only real difference is that the duration highlighted in the end date here is 3 months instead of 2 weeks. The other difference is that the load time series is a little bit more dramatic, representing some of the issues that modern power systems are facing with additional solar net load from solar installations. So there's some of the duck curve effect is represented in the load time series. And just like the previous phase, at least the output files that we are generating remain the same. So with that, we'd be happy to take a couple quick questions before we're out of time. Otherwise, we'd be happy to answer questions on the forum, the Top Coder forum as well.
Clayton, we have a couple questions in the chat.
Yeah, so to the question about the score, yes, we had one issue. It's a path issue, so that I think we can have it fixed tonight. I've had back-to-back meetings all day, and we'll ask the Top Coder and have the resolution. Just need to push it and have the Top Coder team implement it. I believe that November 11th at 16:26 is exact, and I think it's in your local time because I think I see 14:26, but I don't know. What that would be the other way around. So I'm not sure if it's local time or not.
It is exact, though. I can confirm that it's exact. I'm not sure about the local time versus Eastern time, but
no, I'm not sure either. Hydropower function is correct. I
noted that I'll look into that. I don't have it off the top of my head right now, but I'll take a look. If you have any specific, Bruno, if you have any specific questions about why you might not like what's in there, please feel free to post that in the forum just to give us a little bit more of a clue of like what might be the issue. But we'll review and get back to you.
And then I'm not sure what the question about the submission format is. I think that the rules document does lay it out in pretty strong detail. I mean, in terms of the there's a template for the technical narrative. There's an example of a CSV submission file. If you follow that exactly, you should not have problems. I don't know what else to offer. So.
And to go back to the question on the time, I did confirm that it is in your local time. So it automatically adjusts.
Any other questions? Is the score running 48-hour rolling horizon optimization? Yes, it is. It is running 48-hour windows with 24-hour intervals. So once every day, optimizing from midnight that night to 48 hours later, and stepping forward 24 hours and doing the next one. The input of each subsequent problem is informed by the first 24 hours of results of the previous problem. So computing LMPs, do you keep the hydro generation fixed? No. I'm not quite sure I follow. The LMPs are a function of they're the dual prices on the power balance constraint. And so do we keep hydro generation fixed? Hydro generation, the value is the optimal dispatch point, which would govern the LMPs. I think that's how I want to describe that. Sorry.
I'd say if that's not quite clear, feel free to follow up in the forum, and we can.
Yeah, in the forum, we also answered some very similar questions in a lot of detail in the previous two phases. So I would encourage you to look at those threads, and I think they're available in the, or maybe
I'm not entirely sure if they're available. We'll have to look into that.
Okay, I will check, and if not, I can ask Kelly to try and copy them over. But anything else? Thank you for the questions. And anything, Abby?
Oh, I was just gonna say we really appreciate everyone participating. It's been really cool to see the really unique ideas everyone's had. So we appreciate that. We also appreciate your patience, because this has been a cool learning experience for us too.
Yes, and thanks for the great questions in the forum too. They've really kept us on our toes and made sure that we're explaining things well. So like, absolutely, if something's not clear, just let us know. So thank you.
Thanks.